Welcome everyone to this afternoon talk on Shadowboxing your way to secure application. I shall start with the obligatory. We should do introduction. So, about me. I've been in information and IT security for about 12 years. I used to put my IT experience up there, but now then it'd be 17 years, and that makes me sound old. So I've dropped it, and that was just my security time. I mainly do security testing. So my day job is, I don't get to write code as often as I would like. I tend to write like little scripts that say, help, I need to automate this really quickly. And so all my code is really ugly. There's some on GitHub, you can see how ugly it is. So I do security testing. I test web apps, I test infrastructure systems, test VoIP systems, wireless systems, pretty much anything. And I'm the OWASP chapter lead for Scotland. Can I have a quick show of hands? I always ask this every talk I do, so I do apologize. Who's heard of OWASP? Excellent. Cool. So that's getting better, so those people will be happy. So OWASP, for anyone who doesn't know, is an open source group they've got a whole bunch of projects which are freely available, and they have chapters. So it's all about web app security. So there's tools available, there's learning stuff available, there's developer guides available, and there's chapters you can go along and talk to about security stuff. So they're really useful. Check it out if you haven't. And I'm director at Scott STS. Now, at the bottom you'll see a hashtag or an @ If I go too quickly, I have this bad tendency to talk too quickly when I get started. So just tweet at Hey Rory, slow down, and it should pop up there. So if that fails, just shout at me. So what is this talk about? This is actually my fourth Scottish RubyConf talk. Well, Scotland on Rails or Scott RubyConf talk. I always talk about security. So this one's about tools. This one's about kind of automated tools that you can use to help you secure your applications. Where they work, and probably more interestingly for me, where they don't work, where they fail, which turns out to be quite a lot. You get two different approaches. So you get black box and white box. See, and I knew that was going to happen. So no more hey moms, just slow downs. So I'm going to look at the pros and cons of both these types of tools. Because when I do my job, so I do it generally quite quickly. So I'll get anything from literally 1 day. So someone will say, 1 day, assess that application, write a report, and you're gone. Up to maybe 5 days. So automation becomes really important in that kind of circumstance because you don't get time to do stuff manually. So let's look at black box first. So black box testing tools have been around for quite a long time, both for all types of security testing. And essentially they involve building up a picture of the application and then trying to work out whether it has certain common security issues. And doing that without understanding the code that it runs. So the idea of these is you can run them on a Java app, you can run them on ASP.NET, you can run them on Rails app, you can run them on anything, and they should run equally well. So how do they do that? I want to talk about how they do it, because if you talk about how they do it, you can talk about how they fail to do it. So the first thing you have to do, so basically two phases. There's crawling, then there's scanning. So we'll start with crawling. So crawling is what you do to build a picture of the application. So in order to know what to test, in order to know where I can put my strings that might tell me the SQL injection in this application, I have to know what the application looks like. So I have to build a picture of the site. So thus crawling. That's the common way a black box tool will do it. So Google does crawling, everything else does crawling. It sounds really simple. It's one of these problems when you start doing testing. I thought crawling, that's really easy. I just parse some HTML and extract links and move on, and I'll have a great picture of the site, and it really isn't that easy. Anyone try to write a crawler for sites? It's really horribly not easy. So build a picture of the site from a starting point. So you start your starting point, generally the top level of the site. You parse the HTML and you parse the JavaScript. And that's kind of a change. Used to be you could just parse HTML and you'd be fine. These days, if you don't parse JavaScript, you're stuffed. You commonly, it won't work. I was actually doing a test just last week. And I went to this administration page for a Sun server. It downloaded 95,000 lines of JavaScript when I went to the login page. So if your crawler doesn't understand JavaScript, it's got no chance. The entire thing didn't use standard URLs at all. It built them up from JavaScript, which was really wacky. And that was Sun. So we're talking big companies, just got this idea that everything should be JavaScript. So you extract links from the page, visit each resulting page, rinse, repeat, and I have a picture. It still sounds quite straightforward. That still sounds fairly easy. So let's talk a bit about why it might not be. Here's a really basic site. This is really kind of, and what I'll do is just walk through each of these and say where we might have some problems. So we start off, we index HTML. Now index HTML is really easy. It's just standard HTML. We parse that out. We use probably Nokogiri or something similar, and we say, right, where's all my links? Put them in a list so that we can now say, here's where all my links are, and we move on. So we move on, and we get something like standard REST pattern. We get users 1. Okay, great. That's easy. We can parse that, and we do want to parse that. So we're on a live site, we want to parse that, and we extract our links, add them to the page, move on. Now we get, users 1 edit. Do we want to parse that? Well, we probably do. So we probably want to crawl that area of the site, because we need to build a full picture. But if you're on a live site, you're starting to run into areas that maybe you want to be a bit careful with. So if you run a live site and you start parsing edit pages, you'll start editing real data. And depending on who you're logged in as, that could be potentially dodgy. You know, if you start seeing customers of your site whose details start changing because your crawler crawled their site. Again, so now we're starting to run into slightly more difficult places. Okay, now we find a link, http://someothersite.com. So do we want to crawl that? Do we want to go to the other site and crawl that link? Well, that starts to become really interesting, because if you're a tester, that's called off-scope testing, and it gets you chucked off site. You know, you get chucked off site if you go off scope, because someone will think, oh, you're attacking this other third-party site, and that's not right. However, say we use a third-party service, say we use something like PubSub service, where we send data out to them, we get data back. If you don't follow that link, you're not going to know about it. So your picture is no longer complete. And the more third-party sites and services you use, the harder it is to actually get a complete picture from a crawler. So, okay, users 1 delete. Whoa, now we're heading into dangerous territory. Do you want to crawl delete links? Well, you'd hope that a GET request to a URL like that wouldn't, under any circumstances, delete data. Unfortunately, that's not the way it works every time. It works that way if you've done it right. I have seen instances where crawling a site deleted the entire database on a live system. And it was a one-day test, so the people doing it didn't have much choice. They were just told, go in and crawl it. And they did the crawl, got a call saying, what have you done to our data? Nothing. We just crawled it. Unfortunately, deleted the site. So you have to be really careful. If you're a black box tester, or if you don't know exactly how a site's laid out, you have to be really careful when you start running into things like that. And it won't always be as obvious as it says delete in the URL. You know, it might just say parameter, whatever, and you won't know. So, okay, crawling is looking a bit less appetizing now. What about post hash bang my post? So, okay, we're doing a JavaScript app. Again, this is where your JavaScript parsing comes in. If you can't parse JavaScript, an ordinary crawler just says, that's a fragment identifier. I don't need to worry about that. I'm not going to touch it. But if you're parsing a JavaScript app, it says, actually, that's how I identify what page I'm going to load. So your parser has to and most of them don't understand JavaScript. Some of the tools, the more expensive commercial ones, do it, but by no means all. So if you're looking at tools and you want to do this kind of stuff, knowing about this. Okay, and then tags ID equals something. You parse one of those, right? I parse the first tag file. Great. I've got a list of content. There's my contents come back. That's a unique page. Then I get another one with tags ID equals something else. Do I parse that? Different content comes back. Okay, it's a different page. What if I've got 10,000 tags? What if I'm something like Twitter and I've got 10,000 different tags? Do I want 10,000 different instances of the tags page in my crawl? So we're going to slow me right down. So again, so there we go. There's some examples. You say, right, okay, say I can resolve all these problems. Great, I've now got a good crawl, and I've got my site sorted. Who were you logged in as when you did this? Were you logged in as an admin? Were you logged in as an ordinary user? Were you logged in as some special type of user? Depending on who you were logged in as, you might have seen different URLs. You might have certain ones would have been visible, certain ones wouldn't. So again, that makes crawling harder. What time of month did you crawl it? Say I'm doing an accountancy system, and end of month, certain things are only available end of month. Well, gee, if I didn't crawl it end of month, I've missed pages, I've missed content. So crawling's hard. Crawling's real hard, but that's how black box tools work, most of them. Now we've done all this. We've got our crawl completed. We've got our URLs, and we want to scan. So scanning, basically, what you do is once you've got this list, you've got a list of all your parameters, you've got a list of all your URLs, you then poke them, as for want of a better word. Black box testing, I always think of as like putting sticks into a box, and you're trying to hit the vulnerability inside the box, but you can't look inside. So you basically have a series of sharp sticks, which are your vectors, and you stick them into the box, trying to hit something. What type of things are you trying to hit? Cross-site scripting, SQL injection, so input validation issues. Configuration issues, those are really easy to find. So things like you haven't set cookie flags, that tends to be really obvious. And deployment issues, so people leaving the redundant files as part of the deploy, that's depressingly common. You'll see things like something.old, something.back. And those are great because the interpreter doesn't hit them, so you get the raw source code back. Handy for a tester. So how is it done? How do we actually do this? We use something called fault injection. Fault injection is a term. It just basically means put things in and see what comes back out again. So what do we put in? We have a list of test strings. And this is where actually, I was just thinking about this, crawlers don't handle, or scanners don't necessarily handle Rails apps well, because the vectors they have aren't really adapted for, as I said, this is generic. These tools are all generic. They work across everything. So the vectors they use tend to be standard ones. So if your app is unusual or weird or does things in an odd way, this stuff won't work. So we have or1 = 1, standard SQL injection. That's standard cross-site scripting, and that's standard command injection. So, that's something we would put in if we were trying to, and we see something coming back from that. Yeah, you've got command injection. So things like that. And the scanner will build up a list, and it knows to use all these. Okay, eject it into each parameter identified in the crawl. Now, if you think back to our crawling example, then we had a situation where we could end up with tens of thousands of pages. And then we could end up with every parameter on those. And then we have to inject each one of these strings into every combination of parameters that we have. And you start running into huge numbers of requests. So one thing I would say, if you are doing this kind of stuff, don't do it on a server that you pay for the bandwidth, because it will cost you money, potentially. I did this a very quick example, black box crawler across a page with, I think I had like 3 pages, and I had about, a couple of controllers, nothing serious. 11,000 requests later, it finished. So you can see how you could easily end up with a big site spending an awful long time. So we inject into each, and then what do we do? How do we tell whether there's a problem? So there's a number of different ways of doing that. The really obvious one, get an error message back. Error messages are great. Error messages tell me there is a problem with this application. So classic one is SQL syntax error near X. That's really easy, SQL injection. Look for JavaScript in the DOM. So if there's JavaScript showing in your return page that you weren't expecting, that's probably an issue. And evidence of file inclusion, yeah. So if you see the contents of etc password in your returned file, it's a fair bet you had a problem. The other thing it will do is they'll look at other things about the request. So look at the response code. When I did my base request, did I get 200? And then I got 500 on the second one? Well, that's potentially a problem. Content of the response, if I got something like 500 bytes back on the first request and 10,000 on the second one, then again, probably a problem. And time to respond, how long does it actually take it to come back? So you can do blind SQL injection testing where you inject wait for statements. You inject a SQL wait for statement into it, and if it takes 20 seconds to come back, yeah, that probably did the job. Unfortunately, the only problem with that one is if the site only has one database connection, you crash the site, because the database is sitting there waiting for 20 seconds to respond. I've done that. It was loads of fun. Okay, and brute force, this stuff is less relevant if you're the developer of the site. I kind of mention this stuff because it's something we see on tests a lot. So it's something to be aware of when you're building sites and services. Don't leave stuff like PHP, if you use PHP, okay, not PHP, but anything like that, don't leave stuff like that lying around the server in deployment. FCK editor is a classic. You see that a lot included in CMSs, and it has file upload capabilities. So if you've configured that properly, left it lying on your server, you can upload content to it and execute it, which is pretty much game over. Yeah, deployment files, Git, SVN. And as I said, this sort of stuff scanners are great for, because no mortal human is going to go around and do the 2,000 or 3,000 different common things that are on a platform. No one's good. So scanners are great for that. They'll automate it away for you. They'll do the job for you. You don't have to worry about it. Run the scanner, look at the response. Cool. So what are the advantages of this approach? It's zero knowledge. Like I said, you don't have to know anything about the app. If you have a situation where perhaps your company has acquired a new application or you've got an appliance, common one is all appliances tend to be embedded web servers these days. If you're a bit dubious about the appliance and think, I wonder if this is actually done well, you could run a black box scanner on it and actually have a look and see what it does. Coverage. They won't get bored after the 500th form. Humans get bored if you make them do this. I do anyway. So a black box scanner will sit there quite happily and go through every form in your site, and it will find stuff. And confirmed issues. Generally, if you get things like database error messages back, you know for a stone cold fact you've got an issue. It's not debatable or potentially, and I'll talk more about this when I get to the white box scanning side. So what's the problem? Coverage. Coverage is also a disadvantage. Like I said, in crawling, it's really hard to build up a picture of URLs of your site. It's really difficult from a black box perspective to make it accurate and to have any confidence you've actually hit everything. It's potentially destructive. I never run fully automated scanners on a live site. Running fully automated scanners on a live site is a recipe for disaster. I tend to do kind of like individual pages, because you just don't know what's going to happen. And mapping issues to code, you give someone an issue, you can give them a page, you can maybe give them a parameter, but you can't say where in the code base this issue actually is. So you can have, sometimes depending on how the application is constructed, it can be quite a job to actually say, this issue actually turns up to be in this library, or this page, or wherever it is. And this being practical, I should talk about tool options. The really good thing about black box scanners is there's tons of free stuff. There's good free scout options. There's Arachne, which is on GitHub, which is written in Ruby as well. So if you need to look at the code and see what it's doing, if you're a Ruby developer, it actually becomes slightly easier. There's something called Skipfish, which comes from the guys at Google. The only thing I'll warn you about that is it goes really quickly. It's written in C, it's insanely fast, and it will crash your stuff if you have problems with like bandwidth or CPU or anything. If someone, it's like almost like a little denial of service if you don't use it right. You can slow it down, but in default configurations it will crash stuff. And then there's an OWASP project as well. That's different. This is like so the other model of these scanners is you have like a proxy. So you have a tool that essentially, instead of just running at, you sit it in between your browser and the app, and you watch the requests go back and forward. The Zap's more that model. And it's got some scanning capabilities. And there's commercial stuff too. So again, the other good thing about black box scanners is there's a whole lot of options you can use commercially. The HP and IBM, if you've got lots of money, have got options, and there's some other commercial ones. Burp Suite, I'll mention. If you're kind of a web app tester, almost everyone uses Burp Suite because it sits there and it's got lots of options and functionality for playing with requests. You know, fuzzing requests, changing requests, doing anything you want with HTTP. Burp Suite's pretty much got an option for doing it. So generally, if you're a professional tester, you end up using this because it works, and it's not that expensive, like £200. So when I did all this and when I was testing, I did black box testing for quite a few years, and I got really frustrated because I would sit there going, I'm putting data into a field, and I'm getting a response back that tells me something's not quite right, but I can't work out for the life of me what it is. And you're kind of changing things and modifying stuff and trying different things. And I thought the obvious answer is why can't I just look at the code? Because the code knows the answer here. All I need to do is look at the code, and I'm sorted. So I thought, my mind turned to white box scanning tools and static analysis. Because this seemed to me like a really obvious way of fixing the problem. And then I turned out, well, I'll tell you at the end, but you'll kind of see. Again, unfortunately not as simple as it could be. So what are we talking about here? We're talking about the idea of looking at the code outwards. So looking at actually the code before you run it. You don't actually have to run the code to run static analysis tools, which gives them certain advantages and disadvantages. Basic level intelligent grep. Has anyone used things like findbugs, PMD, stuff like that? So they will grep through your code looking for known patterns of badness. So if you're writing C code and you're using strcpy or something, or you're doing really dumb stuff, then they can find that. And if you've got a big code base you've inherited, they're not a bad idea. Or you've got an old legacy code base that has never been looked at. It's not a bad idea to be running that kind of tool and looking for them, because they will find stuff. But they're limited to problems in single lines. So they're limited to the idea that the issue I've got can be expressed in one line of code, because they tend not to be able to kind of match context. So, still useful. So what else can you do? So there's quite a few commercial tools in this space now, which are unfortunately all hideously expensive, or almost all hideously expensive. And one of the things they do is they try and do data flow analysis. So the theory is that any application will take data, it comes in through a source, and then it goes out to a sink. And if you can trace the data through the application, you can tell whether you've got a problem or not by looking at the data and saying, is it validated as it goes through the application? I'll give you an example. Here we have a very, very, very basic application. We've got a browser. The browser is our source. So our user goes to the data, and he types something into a field, and he hits enter. Okay? He's now put a date, and it goes in, and it hits our controller. Our controller does some things, say it's a post, and it sends it down to the model. Okay, and then maybe we're going to a database. So a database in this case would be a sink. So if you can trace your data path and you can say, hey, my data came in over here, and it went through my controller, and it went through my model, and I didn't see anything which stopped SQL injection. I'm using raw data here, and I didn't see anything which would have sanitized that information. I can say, that's SQL injection, with not a complete sense of confidence, but with a level of confidence, in theory. And then, of course, it would go back out to a view in a lot of cases, and it would end up and this is a sink as well. So the browser is a sink. Anything where your data ends up is a sink. And so the theory of this kind of approach is, I should be able to model all this. Can anyone see the really, really horrible problem? How many paths are there through an application? How many conditional statements are there in an application? How many external libraries do I call which send my data off down some other path? And in Rails apps, if I'm doing things like method missing, might my data go through weird funky loops that are hard to predict? Yes. Basically, if you want to do this, one of the problems a lot of these tools have is they'll take hours to run because they try and trace every single path through your application and then look and do taint analysis through every path. And it becomes very, very quickly impossible. And with things like Rails apps where they're quite dynamic and they're quite changeable, it becomes potentially completely impossible. So this is done and tools do this, but to an extent, yeah. So there's an advantage to this approach, and the advantage is mapping to code. So obviously there's an advantage that says, I can actually say where in my code this happens. And what the tools can actually do in a lot of cases is they can say, here's the data, here's a point where you had a problem, data came in, here's 10 different places it went out of your application. Fix that one, and you've fixed all these 10. So they can actually do that kind of analysis and map it to your code, which makes it a lot more usable. Coverage. Different type of coverage. You can be sure that these things will have covered every line of your code base. Black box scanner can never give you that. You can always have something in your app that a black box scanner can't find because the URL wasn't available that day, the URL wasn't available to that user, whatever. But not the same case with white box. And timeliness. So if the tool's quite quick to run, some of them are, you can do it as you commit the code. This is actually, I think, one of the biggest advantages of this, is if you're using these tools as you're developing, and you're saying, okay, maybe I had some stuff back here, but what's new? What's changed today? Have I found, something new popped up? Because if it has, you can say, right, it's easy to actually analyze that and say, what was I doing? I mean, my limited coding experience, if I find something wrong with a tool the same day as I make the problem, it's quite easy to fix. If I wait 6 months and come back to it, I'm like, what was I doing? How did I get that code to look like that? So it becomes harder for me to fix the problem. So these things, you can do them quite quickly. And that's one of the problems with black box scanners and external pen testers. Not to diss my own profession, we tend to get called in right at the end of projects. So project goes along, 2 weeks before you go live, after all the development's finished, call the tester in. I find something, it's now about a week before you go live, and the developers have moved on in a lot of cases, they're doing something else. And people are going, how do I get that? So timeliness is good. False positives. I put that in quotes. I put that in quotes for a reason. It's not really false positives. The tools, and it ties into this, Prezi doesn't have a big blinking red neon effect, otherwise I put it under lack of context. Because it turns out the lack of context is the complete killer for white box tools. White box tools, when they're tracing things like data, they'll look for a function which sanitizes data. How do they know what that looks like? So unless you know the framework, then you've got no chance. Because a lot of the things that sanitize, for example, Rails finders, if you don't know about how a Rails finder works, you have no chance of analyzing a Rails app correctly, unless you go all the way down and try and do it. Trying to analyze the entire framework, which they don't do. Same with every other framework. So tools that just address your language aren't good enough. They have to address your framework. And what's more than that, they have to address in things like Railsland, they would have to address things like the plugins you use. So if you use devise for authentication, then you have things like devise for in your roots file. If the tool doesn't understand how devise for works, not going to find stuff anymore. So lack of context is what makes it really, really hard. The tool has to understand to an extent how your entire environment works. And false positives are the other thing. Because it doesn't understand that, a lot of them will kind of tend on they'll err on the side of caution. So they'll throw up a whole lot of issues and say, hey, I think this might be an issue. And it can put people off. So you run it the first time, you get 10,000 issues, and you go, whoa, don't have time to do that lot. Let's just quietly move on. So, but it is worth looking through, in my opinion. Working with them and actually saying, right, okay, this class of issue, no, they are a problem. This one's, they are, yes. Right. So, tools, unfortunately, is not as nice a scenario as black box. So we have, who has used Brakeman? Okay, everyone should be using Brakeman. I'm not being funny, honestly. I mean, for all I've said about the bad things about, if you're writing Rails apps and you're putting in production, use Brakeman, because it will find certain things for you quite well. Don't get a false sense of security that it's secured your application, because it's not a magic bullet. But it takes about 15 seconds to run on a small app, probably a couple of minutes to run on a big app, and some of the stuff it finds will be quite useful. If nothing else, it will tell you when new versions have got security fixes in them. So if you're not on the mailing list, that's the other thing, you should all be on the security mailing list if you're not, because otherwise you won't find this stuff. There's a couple other ones. RORSEC scanner is an old one, which apparently SUSE used to use. It's more kind of your basic grep style tool. And Scanny is, at the moment on their GitHub page, they say this is not ready for use yet. But, it looks quite promising. There's a lot of commits, a lot of activity, so worth looking at. I'll mention the commercial stuff in case anyone's got lots of money. So by lots of money, what do I mean? I can't speak for the vendors, but my experience of an on-premises installation for any of these is 5 figures. For the IBM and HP ones, you're probably talking 6 figures. So we're talking a reasonably large amount of cash. That may change, obviously. I don't know. Don't want to get beaten up by IBM. HP, Fortify, and AppScan, those both cover a lot of different languages. They'll cover every language you ever wanted to do because they sell to enterprise. Checkmarx is another good one. It's cheaper than the other two, and it does do Rails coverage, which is fairly new for them, but they do it. And then there's lots of other ones. I mentioned that one as one, but most of them don't cover Rails. They cover things like Java or C. Rails support, I personally think, is really hard for a static analysis tool because it's so dynamic. And because things change quite quickly, I'm not sure how good their support will be. So, when I read this presentation, I've done this a couple of times now, and I kind of feel it comes across a little bit negative, and it really shouldn't. There are good uses for automation. White box tools are worth using during development. So if you're developing an app, something like Brakeman, I personally think, is a good thing to run. It doesn't cost too much, it doesn't take too long, and it will find stuff. To my mind, that's like an easy win. But run them during development. Don't leave it till the end. Don't leave it till the end of you're about to go live and say, oh, we better run this Brakeman thing. It's much better to run it incrementally and get what's changed today, what new code has gone in, what issues perhaps been happened. Black box tools are useful when you've got the complete application. Because the thing about white box tools, the other thing that I should mention about context is they don't know about your JavaScript libraries. They don't know about your framework. They just know about your code. Black box tools will look at the whole thing from top to bottom. So they'll look at how you interact from the browser down, through your JavaScript libraries, through your web server, through anything that's visible essentially on the site. And that's a strength of black box tools. So when you've got the complete thing together, get an environment that's not production, get like a test environment that's close to production, looks like production, and run a black box scanner. Again, they don't take too long to run. They do take a bit of tuning to get the best out of them. I won't lie to you and say that they're kind of point and click. They really aren't. But you can find good stuff with this. And if your application is the kind of application where you are looking at paying external consultants to come and look at it, run these first. Apart from anything else, it makes the external tester work harder for their money. Because if all the easy stuff is gone, they have to really work hard to try and find stuff because they don't like it. No one likes an empty report. So they'll work really hard to try and find something. So you might get something cool and interesting if all the easy stuff's gone. And the easy stuff comes from scanners. That's how I find my easy stuff. You know, when I'm doing a test, the first thing I do is run a scanner because why not? And I will find good findings, and it's great. But I'd personally prefer all that stuff to be gone so I could maybe try and do something cool. So they both have pros and cons. Yeah. Ultimately, they both have their limitations, and that's kind of the message, I suppose, from this. They're worth using. Understand where they don't work, because if you understand where they don't work, then you can understand where they do work and where they'll be useful to you. And you really need, grey matter. Hey, bit of a pun to go with the shadowboxing thing. You need grey matter driving it. Human intelligence, ultimately, is necessary to make these things work well. Definitely a lot of the issues I've found in sites you would not have found with a scanner, just because they require a bit of brain power. I have demos as well, so we can do questions, and then seeing how we get on, I have demos, and I have enough time for them too. My timing is not bad. So, anyone want to ask any questions?
I have a question. It's probably not necessarily what you've talked about.
Yeah.
So you're here, and probably you can give some advice about that.
Yeah, sure. Okay, hi. I wonder how to secure like traffic, because I have my setup consists out of like a server, and there's a front end HTTP Nginx, which accepts HTTP connections, forwards them to the upstream backend, and I want the upstream backend not to have any bad traffic. So I've put up some IP tables rules for like filtering out TCP bad stuff, but where to go on from there? Is it in your point of view, is it a good start to like also take care of this kind of security issues?
Yeah, I mean, definitely, it depends. If you're exposing a back end, You know, I would say it depends on what it's exposed to. So if it's exposed to the internet, then absolutely, you should treat it like it's, you know, external facing and test it in the same way. I'm a reasonable fan of, if you've got front end to back end and they're both exposed, locking down by source IP address. It gets people, I've seen a lot of security people say bad things about that. They say, oh, you can spoof IP. No, spoofing TCP is really non-trivial in most cases. Really not easy. So saying, I will only accept connections from this IP address means, well, you're probably not going to face any other issues, because how are they going to make the connection unless they've already compromised your front-end box? And if they compromise your front-end box, then at that point, you could start doing validation on the traffic coming in. So depending on how your API is, if you could say, well, is this well-formed? I mean, you should be doing that anyway, I guess. Saying, is this traffic coming to me well-formed before I process it? But something like source IP addresses, I personally think, is not a bad mechanism for cutting out a lot of the noise anyway. You know, if someone gets past that, they're quite dedicated, and you can try and detect them other ways. Yeah. If anyone, yeah, you can set up sensible rules like, all right, yeah, the 10 dot whatever ranges should never, ever, ever. But then internet routers, if they're in any way well behaved, should not forward that traffic. So, you know, if they're being, and most internet routers are well behaved and will not forward that traffic. But yeah, source IP address filtering is one way of cutting out a lot of the noise at network level anyway. And encryption. Always worth, it's always worth, if you can. SSL is generally the cheap and free way of getting decent encryption. And definitely if it's implemented okay, there haven't been any, or there are not any really serious problems with it.
Anyone else? Do you think that security tests should be part of the test suite, be it an integration test suite or a unit test suite?
Yeah, so the question is just whether security tests should be part of the integration test suite. In terms of timing, I would say that they roughly fall at the same time. In terms of timing, I tend to do security testing, say UAT or around that time, so the application should be functionally complete if you're getting an external tester in. I actually believe that security testing should be done all the way through the development cycle. So when you're writing the code, people should be testing security. Having security testing just at the very end leads to this problem of 2 weeks before we go live. Do we go live or not? In terms of actually putting in with testing, I think there's more that I really think that it's funny. I think that on one hand, there's more that could be done to get security testers to talk to functional testers and to actually try and integrate those two. But the tool set and the mindset can be slightly different, so there can be a bit of a clash there, because functional testing tends to be focused on, or from my experience, tends to be focused on how the application should work, whereas security testing is focused on what would someone think of to do that no one would ever try and do legitimately with this application. So the mindset can be a bit tricky to integrate, I think.
So you don't think it's a development responsibility?
To security test?
No, to actually consider the potential holes in the code they write.
Oh, absolutely. Yeah. Oh no, I mean, I think if you're writing code, the problem is it's a really, really hard problem. In my experience, working with development, working on that side of things, I've never met a developer who wasn't interested in doing secure coding. What I have met is people who weren't allowed to have it as a priority and who had lots of other pressures on them, like making it functional, making it fast, and making it ship right now. And unfortunately for a lot of management, either it's kind of assumed that security will just come for free, which is a really, really bad assumption, or people aren't given it as a priority, so it tends to fall by the wayside. And also, I will say the level of education. I mean, for all the work OWASP does, and they do a lot of good work, there's still a huge gap in terms of good, understandable, specific advice on security. Yes, everyone should be considering security. I'm a security person, I would say that. But yeah, if you're writing code, you should be considering the security aspects of it. But in reality, how much time do people get to do that? Oh yeah. Yeah, if you're looking at development methodologies, there's a couple of security development methodologies. One called BSIM, the Building Security In model, and there's another one called OWASP SAM. They're both fairly similar. So there are models that essentially describe how you can integrate security into each stage of the development process. You do certain activities at each step. You're during modeling. So you start off when you're doing the design, then when you're doing development, then you do different activities at each stage. And they've actually got some good benchmarking of. I mean, it's mainly for corporates, but they've got benchmarking of how other corporates stack up. So if you're in a large company, you can actually use that to say, hey, we want to be up here, we're actually currently here, how do we get from there to there?
In your experience, how secure would you say Rails was compared to other technologies that are out there?
Okay, that's a really interesting question. So I don't get to test as many Rails apps as I would like. I'd love to be doing more Rails app testing than I actually am. My experience of them is the framework provides you with a lot more than a lot of other languages. So if I was to compare it with other common web things like PHP, PHP apps are, in my experience, a lot less secure because the developer has to do everything themselves. The framework doesn't give them anything. Rails, the framework, will give you lots of stuff if you use its default configuration, and it's getting better as time goes by. And that, I think, is very useful because it's hard to remember security in every context. So the framework does something for you. But there's a real danger in that. And the real danger is that if people get the mindset, the framework's done this for me, I don't have to think about it. And I've seen that actually more with ASP.NET. With ASP.NET apps, it does certain things for them. And I've seen many apps where that stuff's all great. Like input validations, it handled that, everything's fine. Riddled with authorization flaws, because authorization isn't handled by the framework. So if I was giving people advice, I would say, realize what the framework doesn't, like tools, realize what it don't do for you, realize what the framework doesn't do for you. But my experience is that Rails apps tend to be better just because the framework will catch lots of stuff. And it requires effort to make it insecure. You know, the problem would be that the only thing the flip side I'll say on that is Rails is quite fast moving and it changes things. So a really good example is people might think that output encoding, so Rails 3 and above I think it was, does default encoding to HTML. But it does encoding to HTML. If you're dumping your data into JSON or into JavaScript, that encoding won't help you. So it's that kind of thing where you can be assuming something because the framework does stuff for you. It does encoding, I'm all good. No, it does HTML encoding, not necessarily JavaScript escaping or JSON encoding. So it's that kind of subtle problem which can still trip you. But in general, I'd say better than most, would be my opinion. Yes. Yeah, there's lots more web services stuff. And the other, yes, you see a lot more, even people just exposing web services, which makes testing kind of interesting. The other thing is that people tend to use third-party services a lot more. So I did this test where it was for an American company. And I was testing their integration with other services. And essentially, they backed off to Amazon S3. And then they passed it to a third party, who backed off to Amazon S3. And all of them, it was just a series of things sitting on EC2 going back to S3. And the fact that that was all exposed, so Amazon, as you know, uses a key. So it uses a key, essentially, which you provide to say, I'm authorized. If you lose that key to your S3 bucket, as far as I'm aware, someone can just read all your data. And so things like key management become important as soon as you expose that, where if you were in a traditional architecture where everything was back behind the firewall, you were just exposing your web server. That connection to your data store is not exposed to externally. Fair enough. Yeah, so the web services stuff. In general, web services you see people expose methods they perhaps don't mean to. I've seen a lot, again, actually, I'm picking on ASP.NET and I don't mean to because they are actually generally quite good. But the default things, so ASP.NET web services ship with an ASMX file, which describes every method that the web service supports. And it's there by default. It's great for a tester because they mainly use one function and I've got access to all of them and I can try and poke them all and see if they're actually secure. So yes, you're exposing more as you do that. Good. 5 minutes, 48 seconds. I might be able to do a demo. This is the chance, of course, of this working and my demo actually flying when I've got 5 minutes left to do it. What do we reckon, about 5%? So here I have a very, very basic application called Vulness RC Twit. It's just a Twitter clone, why not? If I can make this work. Okay. Lots and lots of GET requests, but there's a post. So there's an HTTP post request. This is Burt, by the way. And you can actually see the HTTP post, and you can see there's my text that I entered in. Now, as a black box scanner, I should be able to right-click this, and I should be able to say, do an active scan. And it'll go away, and it will do an active scan. Here's my scan queue. Oh, and it's got a big fat red. And the big fat red it's got is cross-site scripting reflected? So that easy. I mean, okay, I had to hack about this to make it. I will point, actually, if you see the screens, I got this off a tutorial. The vulnerabilities are not his, they're mine. I put them in there. So the guy's tutorial was great. I put the vulnerabilities in. But anyway, that's how easy it can be to use a black box scanner to find cross-site scripting. The only thing I will say is once you've done this, is it finished? It's still doing its stuff? Finished. Okay. So it's done that. What happens if I refresh this page? Oh, so if this is a production app, I've now got nice little pop-up boxes which shouldn't be there. I've also got, yeah, an absolute stack of requests. So this is what I'm saying about if you have a black box, if you've got an application and you run in production and you run black box scanners, expect this kind of stuff. Feedback forms are a favorite. You know, if you have a feedback form that goes to a contact center, they are not going to be your friends if you run a black box scanner on it, because they will get hundreds of those, and they will not be happy. So that as a really basic, that's black box. Yeah, it turns the whole thing into garbage and links and stuff, and that's just from one request. So I should also be able to do. Oops, helps I can smell. So, right, that's Brakeman. That's how fast it is to run Brakeman. And I should be able to go in, do file, open file, okay, and that's, this is the Brakeman output. And you can see what it's found is it's found that I've actually got a mass assignment vulnerability. So I mean, I'm guessing people saw the GitHub problem a while back. It was mass assignment. I mean, again, because this is a Rails like 3.2.5 app, I had to really turn stuff off to make that work. But that's in terms of trying to find issues with Brakeman. That's how fast you can do it. You can find mass assignment, and it's got a couple of things. It's actually got cross-site scripting. That's not the same cross-site scripting. Strangely enough, Brakeman won't find that first one, which is for interesting reasons. But and it also found a SQL injection. So, and that's the thing I was saying about versions. So Brakeman will tell you, hey, look, you're not using the latest version of Rails. There's a SQL injection in the latest version of Rails. You should totally upgrade. Yeah, and tells you where it is. And in this one, I think. So, two very quick demos, but hopefully pointed out that, you know, hey, black box tools can actually help, and white box tools can actually help. And they're both fairly easy to run. Any other questions about those quickly, or am I good? I've only got 2 minutes, 12 seconds left, almost out of time. Are we good? Yeah? Exactly, yeah. They've also got a Guard plugin, so you can plug it into Guard and have Brakeman run with Guard. Brakeman's still in development. There's still stuff they need to do, but for me, I said it's free. And open source tools, code review tools are not usually free. So a free one, absolute bonus. And, you know, they can give you quite a lot, which is good. So that's where the rest of my presentation comes in, and don't assume that this has fixed all your problems. Do not assume that a clean Brakeman run and a clean scanner run mean you're all good. But they should help you give some confidence that certain classes of vulnerability have been addressed. Cool. Great stuff, thanks very much.